When I first started using GitHub Copilot in Visual Studio Code, I kept to the chat window as it was more friendly and intuitive for me. I wasn't too comfortable with the idea of using the CLI for chatting with an agent. Over time, I've been using GitHub Copilot CLI more often. As the scope of my work increases and as demand from stakeholders also increases, I found myself firing up multiple terminals to do different tasks on a project. However, I've had to be careful about how I've done this, as I didn't want to have to deal with the trouble of merge conflicts only made worse by overzealous coding agents. A colleague of mine suggested that I take a look at tmux and Git worktrees as a method to safely work on multiple features within the same repository, and use the GitHub Copilot CLI to use agents to work on each worktree without compromising the other's work. I'd never used tmux before, nor have I ever really used Git worktrees in anger before, so in this video, this seems like the perfect excuse to hack on both and learn something new. tmux is a terminal multiplexer that allows you to create, access, and control any number of terminals from a single screen. What's different about just splitting the terminal or creating a new tab in Windows Terminal is that with tmux, you can detach from a session and reattach later through persistence. The running processes stay alive across disconnects and reboots, and this is great for remote work because if the connection drops, you can pick up exactly where you left off. So let's take a very quick tour of tmux before we get started. So I'm using a Windows device, so I have to use tmux through the Windows Subsystem for Linux, or WSL2. Now that's not a bad thing, it's just that tmux doesn't run natively on Windows. There is a native substitute called psmux if you're not comfortable with WSL2, but the rest of this video is going to assume that you are running the Windows Subsystem for Linux. And if you're not, I've popped a link in the description that shows you how to do that. But provided you have installed that, we're going to have to install tmux. So that's sudo apt install -y and then tmux. Now, usually it'll ask you for a password and then it'll go ahead and install tmux, your Linux password. But now I've already installed it, everything's upgraded or updated to the latest version, so that's available to us. So I'll clear that. Now, the first thing we're going to do is create a new session. So a session is a collection of windows. It's a persistent workspace that survives disconnects. It's the highest level of organization in tmux, and essentially you can detach from a session and leave it running in the background and then reattach to it later, which is tmux's superpower. So in order to do that, all you have to do is tmux new s demo. I'm calling my session demo. So I'm creating a new session and there we are. Now what's happened here is I've created a window. So windows are like tabs in a browser and each window can contain multiple panes which has its own command history. The thing that really tripped me up when I first started using tmux is the idea of the prefix key. Every tmux command will start with us pressing Ctrl B together and then pressing the actual command key. So to split this window into two panes, essentially I've typed in the prefix and now the %, and there we go. I've got two panes. Now to move between them, there's no mouse mode installed by default. You can do some config editing to enable that. I won't cover that in this video, but in order to move between the panes, I click on the type the prefix key again, and then I can use the arrow key to move between sessions. Now, if I press the prefix and then press D, that's detached from the session. So the session has vanished, but it's not gone. It's still running in the background. So if I go tmux ls, there's my demo session that I've created earlier. And I can go ahead and actually reattach to that. So I can press tmux attach tdemo, or type that in, sorry. And there we go, everything's exactly where I left it, which is pretty cool. So you can imagine if I'm running multiple agents in different panes, I can just detach from that, do something else, and then reattach to it and come back and see what progress they've made. So I'll go ahead, Control B and then D to detach again. And then I'll go ahead and just kill that session by tmux session and then the name of the session. And then if I try and list that again, that session doesn't exist because I've killed it. Now let's talk about giving each agent its own workspace using Git Worktrees. Git worktrees allow you to check out multiple branches from a repo at the same time, with its own isolated directory, but all sharing the same Git directory. This provides our coding agents with a reasonable amount of isolation. Since each worktree has its own directory, this will prevent autonomous agents editing the same directory from stepping on each other's toes and creating merge conflicts in real time. Now I have this API project here, and what I need to do is harden it up a little bit. I need to add tests, I need to add a Docker file, I need to add a CI pipeline, and I also need to add a dev container. So I'll create a worktree for each one. Each git worktree add command will give me a new branch and a new folder, sitting next to the repo, not inside it. They'll all share the same git history, but each one will have its own working directory. So 4 agents required to do each task will have 4 folders and 4 branches, all completely separate from each other. So back in the terminal, I'm going to create one git worktree per task, all in sibling folders like so. Now if I type git worktree list, I should see all of my git worktrees that have been created. Okay, now that our git worktrees are ready, we're going to create the tmux session. We're going to tile it into 4 panes plus a control pane. We'll cd into each of its worktree and then run Copilot in each. So I'm just going to copy and paste that. And that's essentially going to create a new tmux session with 4 different panes plus a control pane for me. So there we go. There's my 4 panes up here. And then this is the pane that I'm going to use for my control pane. Now let's run our agents within each one of these panes. Now the CLI will normally stop and ask permission before it edits a file or runs a build. If you want it to just go and do things, we can add a parameter allow all tools. I'll be honest with you, I'm still not entirely comfortable YOLOing 4 agents at once for my work, but this is just a demo, so we're going to have a bit of fun with it. Okay, I've taken myself off screen just so we have a little bit more real estate. And I'm going to use this bottom pane to send commands to all of these other panes here. And I can do that using tmux send keys. So essentially what you can do, I'll press enter and we'll have a look at this one. So tmux send keys, essentially we can send commands to one pane from another pane. So this t tab or t pane is essentially saying, okay, to this swarm 0, so this pane here, we're going to invoke Copilot or allow all tools, and then this interaction. So add an XUnit test project, fix API tests that references the API and covers the endpoints with web application factory program. Add new files only, don't edit the program CS. And we're going to send all of these 4 commands to these 4 different panes. So if I press enter now, I can see that those sessions have been, or prompts have been sent to those 4 different sessions, and they're working away in the background. This is the payoff. So I've got 4 GitHub Copilot agents all on one screen working at the same time. Let me see if I could just come out a little bit. This will be very, very small, the writing, but essentially this one's scaffolding my XUnit project. This one is going to write the multi-stage Docker file. This one should be writing the GitHub Actions pipeline. And then this one is going to set up a dev container. So 4 tasks that would have taken me the best part of an afternoon, one after another, switching between agent sessions. They're all just happening at once. And that's the whole point of a swarm. You're not waiting in a queue anymore. And because tmux is holding, and because this is running in tmux, I can actually step away. So Control B and then D, detach from the session. I can go tmux ls and then tmux attach t swarm. And there they are. They're back in the session doing their thing again. Okay, through the power of video editing, all agents are done. Now for the moment of truth. So let's check what each agent left behind, commit it, and then push all 4 branches, raise a PR per agent, and then see if we can merge them. So I'll detach from this session using Control B and D. And what I'm going to do now is essentially see what the agents have left behind. Okay, so I can see that the tests branch, or in the test branch, or worktree, sorry, the fixtures API test has been added. In the Docker, I've got a Docker ignore file and also the Docker file itself. In the CI Git worktree, I've got a GitHub folder, which will hopefully contain some GitHub action workflows. And then in the dev container worktree, I've got a dev container folder there. So they've written the files, but they haven't committed them. So what I'm going to do is just copy and paste. I'll just clear that, get a bit more real estate, and then I'll go ahead and commit it for each one on its own branch. So that's all been committed. So now what I can do is I can actually push all of that up. Just clear that up again. And now I'm going to cheat even more, and I'm going to use the GitHub CLI to create 4 PRs. And there we go. There are all my pull requests created. Okay, now I'm going to use the GitHub CLI to list the PRs, and then I'm also going to see the diff. So I'm going to print just the file paths that each PR touches, no diff content. So I'll go ahead and run that. And as you can see, so there's my 4 pull requests, and then these are the files that are in each pull request. So as you can see, none of these files have touched each other. So agent 1 and agent 2 haven't worked on the same file. So hopefully we should be able to merge these without causing any conflicts. And just looking in GitHub, I've merged everything back into main, but I'll click on the unit test project pull request, click on the files changed, and I can see that it's only C# test files that have been changed in this PR. I'll open another pull request. I'll look at which one should I look at? The GitHub Action CI pipeline. This one I can see that if I go into files changed, it's only the CI pipeline or the YAML file that has been changed. So looking at these changes in main, in the repository, this fixtures API, I can see that tests have been created. The dev container has been created there. There's my CI pipeline, and then the Docker file and Docker ignore file. So that's how you scale from one agent into a swarm of coding agents. So we use tmux to give us panes and persistence so we could run multiple coding agents at the same time. And we combine that with Git Worktrees to give agents a clean, isolated workspace. So every agent will have the ability to work on its own files and prevent the merge conflicts that can cause nightmares when working with multiple coding agents simultaneously. If you like this video, give it a like. I've got a full written walkthrough of all of this on my blog, so I'll put a link to that in the description. If you have any questions, pop them in the comment section below. And if you're working with your own agentic swarms and you're using something different, or you're using tmux, I'd love to hear about it, so pop that in the comment section too. Thank you so much for watching, and I'll see you all next time.